When we talk about relief shading, what we're talking about is a grayscale shading of a map or a three-dimensional map where the shades of gray are varying based on a theoretical light source shining down on the terrain. This is also sometimes called hill shading, especially in GIS software. Hill shading is a very common name, or shaded relief. And I'll tend to use those interchangeably, especially hill shading and relief shading. I'll show you kind of a slide of historical perspective from some historic artwork, and then we'll talk about what the idea behind relief shading is, look at some relief shaded maps, and then also see how relief shading can be combined with hypsometric tinting, or basically changing colors by elevation in order to make a map. And that's how we'll combine those two. So here's an example of a hill shaded map. This was made by Leonardo da Vinci. It's a map of Tuscany, Italy, made around 1502. And what we can see is that Leonardo has put darker shades on this side of the terrain and lighter shades on this side of the terrain, as if the light for this map was coming in from the upper left-hand side here. And we can see this is consistent across the map. Even though he's kind of traced out different hills, it's really that shading that gives this the three-dimensional effect here. So how could we do that on a map? Well, all we have to do is we have to decide where our light is coming from. And typically for relief shaded maps or hill shading, we use light from the northwest, and we use it oriented about 45 degrees above the horizon. So it's not shining directly down from above. It is not coming in horizontally. It's about halfway in between those. The idea here is that if we kind of think about this as the top of an umbrella, if the light is more directly hitting the surface, it's going to be a lighter shade of gray. And if it's hitting the surface at a very large angle, it's going to be the darkest shade of gray here. So sometimes we talk about this idea of a surface normal vector, and that would be another vector coming off of the surface that's perpendicular to this surface. In this example here, we're showing a pixel here, and this pixel surface normal is shown by this arrow here, and here's our light coming in this direction here. All we need to do to calculate the hill shading is find the angle between the light source and the surface normal for each grid cell or each pixel, and then we've made a hill shading map or a shaded relief map. And in order to find that orientation, we have to consider both the slope, which is represented by this arrow here, how that pixel is tilted, but also the aspect direction, what direction that pixel is tilted in. And once we do that, we can make this sort of shaded relief. This is actually a hand-rendered shaded relief made back in 1981 by Edward Imhoff, a famous shaded relief mapper from Switzerland. And we can see how this really can give a map a three-dimensional effect. This is a shaded relief map of the United States. When the first good digital elevation model was put together for the United States, they made this shaded relief map in order to show all of the various three-dimensional landforms across the United States. Thalen and Pike with the USGS are responsible for this map. So once we get our hill shading or shaded relief down, now we want to add another component to our map, and that's we want to change the color of the map based on elevations. So typically we pick a color scheme where it's somewhat similar to land cover. So for example, we might have white mountaintops, and then further down on the mountains they might be brown. When we get down to the lowlands, it might be green. And if we go into the water, the shallow bathymetry or shallow water depths might be a light blue color, and the deeper water depths might be a darker blue color. Hypsometric tinting or layer tinting, and I'll use those interchangeably as well, hypsometric tinting and layer tinting, gives a good idea of how high the elevation is, but it doesn't really give us as much detail as a shaded relief. So let's look at a map, or let's look at some of these color schemes. Here are some of those color schemes we were talking about. Here's kind of a classic color scheme where you're going from the green lowlands up into the mountains here, up into the purple mountains, and then maybe they're snow-capped just at the top here. But we can see if we only apply this hypsometric or layer tinting to a map, it doesn't give us the strongest three-dimensional effect. We can certainly tell where the valley is and where the highest mountains are, but it doesn't give us a strong sense of where each of these valleys in between and the side valleys off of those valleys are. when we use these hypsometric tintings, we're also making some assumptions if they're really kind of based on what kind of land cover there is. If we're in a warm, humid region, those color schemes like you've seen before might be really good, moving from a darker green into a lighter green through yellows and oranges, and then finally up into whites at high elevation. But if we're in an arid region, it might look more like this, where we're moving from a brownish region up to a lighter region to orange and then up through white. In polar regions, we would just be snow on top of snow. So here we might want to start with a darker blue and go up to a lighter blue. And Patterson and Jenny put these all together onto one map of the United States here and of the world, and we can see how they blend these together. Things kind of come together at higher elevations, but if we're in a humid area, such as the humid lowlands like the eastern United States, we might use one color scheme, but over here in the western United States, we're using a separate color scheme based on whether the area is arid or humid. So how do we combine the shading and the tinting onto one map? Well, we use the HSV color model, and we assign the hypsometric tints to the hue and saturation of the colors we use. This is once again going to lack the fine detail, but it's going to reveal the regional patterns of changes in elevation. The value in the HSV color model we reserve for the relief shading. This is what provides the fine detail. However, remember that the relief shading does not have any information on what the exact elevation is. It's just what the elevation looks like when this theoretical light source from the northwest is shined on the terrain. And if we combine those two, then we can see that we can get a map like this, where we get a combination of if we were just looking at these colors here, there would only be these sorts of variations in colors going from lower to higher elevation. But now that we've added the shaded relief or the relief shading or the hill shading as a background, we can also see all of the fine details. Even if the color isn't varying that much, we get a lot of these smaller valleys and ridges that are very well defined on such a map. Here's another example here. This is a hand-drawn map, but we see both the blues in the water here and kind of the yellow to brownish colors up on the land. But this is really meant to highlight what the ocean floor looks like. All of the topography on the ocean floor that we can't see because of all the water filling in the oceans is what this map was trying to show. Once again, by combining the layer tinting, in this case how deep the ocean is, with the same kind of shading that we talked about before, that hill shading. And here's another example here. This is a historical hand-drawn map, but it's showing a combination of layer tinting. We can see it gets into the reddish browns at the highest elevations and down into these bluish greens at the lowest elevations. And of course, that's all now been automated. And this one shows some of those patterns. We're combining hill shading with elevation, with layer tinting, but we're also adding some other things like the land use patterns and where the glaciers are. And we can also see in this example here by Swiss Topo, the Swiss mapping agency, that they've also added all the contour lines to give us once again a greater sense of how this all looks in 3D. So this is just a nice example of all those things being combined using GIS into a modern day map to make a very striking map of the terrain.